After looking at the intersection of two sets, we are now going to look at the union of two sets. So the union of sets A and B, written as A union B. A U, this U is really formed like a U in union, is the set of elements that are members of set A or set B, or of both sets. So in other words, it's either in A or B, or it is in both of them. This can be expressed in set builder notation as follows. A union B is equal to all of the x's such that x is an element of set A or x is an element of set B. So it's either in one of them or it's in both of them. All right. Let's go ahead and find the union of some sets here. We want to find the union between the sets 1, 3, 7, 8 and 2, 3, 8. So let's have a look what we are going to get. What is this going to be? First, I will pick every element in my first set. 1, 3, 7, 8. Everything in that set. And now I'm going to look at my second set and I'm going to look for elements that were not in set A yet. The number 3, I have already the number 3. The number 8 is already in my new set. The only number that is still missing, that was the number 2. So the number 2 comes as well. This is the union of both sets. Let's have a look at my second example here. The numbers 1, 3, 5, 7, 9, forming the union with the numbers 2, 4, 6, 8, 10. Now, neither of these two sets has anything in common. The first set consists out of odd numbers between 1 and 10. The second set are the even numbers between 1 and 10. So the union in this case, the union between these two sets, well, this is going to be everything from this set plus everything from this set. So in other words, it's going to be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that in the intersection, if this right here would have been the intersection and not the union, this would have been the empty set, as a reminder. Let's have a look how to solve inequalities involving the word or. So, similar to before, we are first solving each inequality separately. Then we are also going to graph the solution sets on top of each other, but we are going to take the union in this case. Think about smashing. We are smashing the graphs both together. We take everything from the top and everything from the bottom. And I can also pick a number out of my solution set to check my answer by plugging it into both inequalities. In this case, only one of them has to be working. So let's do one. 2x minus 5 is less than or equal to negative 11, or 5x plus 1 is greater than or equal to 6. So in words, what it is that we are doing, we are looking for numbers that are either a solution to this inequality or a solution to this inequality. It is different from what we have done before, where our solutions had to be solving both at the same time. It will be good enough if the number that we are picking is just the solution to one of them. The solution way is exactly the same. I am solving my first inequality, adding 5. We get 2x is less than or equal to, let's have a look, negative 11 plus 5. That would be negative 6, if I'm not mistaken. We are dividing both sides by positive 2. And we get that x is supposed to be less than or equal to negative 3. Now, I'm doing the same thing with my second inequality. 5x plus 1 is greater than or equal to positive 6. I first subtract 1 from both sides, and I will get 5x is greater than or equal to positive 5. Now I will divide both sides by positive 5, and we end up with, well, what is 5 divided by 5? Positive 1. Now I am sketching my graphs. This does not have to be very pretty or very perfect. The only important thing is that your number lines are lining up, that they are matching. In other words, the same number line on the top and the bottom. Right here are my zeros. Okay, so my first solution was x was supposed to be less than negative 3. If I say that right here, this is maybe negative 3, less than means to the left, and less than or equal to means I had a bracket right here. I hope that you can see this. Let me put the negative 3 a little bit smaller. This is a bracket to the left and equal to negative 3. The second inequality said x was supposed to be greater than positive 1 or equal to positive 1. So if I say this down here was positive 1, then greater than positive 1 goes to the right. Greater or equal to means I have a bracket. And now we are sketching our solution graph. We are now going to smash both graphs together on one. And what will I get? I will get the first one to the left and the right one down here to the right of positive 1. This is what my solution is going to look like. So, as a reminder one more time, unlike where we had the union of the two sets, the intersection of two sets, which would have been empty, the union of two sets will be something. It will consist out of two separate sets. The set of numbers from negative infinity to negative 3, gap, and then the numbers from 1 to positive infinity. So my solution set, we write like this. From negative infinity to negative 3. And now I have a union sign. And the second set was from 1 to positive infinity. Negative 3 and positive 1 both get brackets. So if I now would pick a number, I would have to pick a number out of either the left set or the right set. If I pick a number that is not in my solution set, like the number 0, I can do this too, but then I expect something different. When I plug in the number 0 into either my first inequality or the second inequality, it cannot be a solution to either one. So if I'm just checking this real quick, 2 times 0 is 0, negative 5 is not smaller than or equal to negative 11. In fact, it is greater. So 0 is not a solution to this. 5 times 0 is 0. 1 is not greater than positive 6. That means it is also not a solution to this number. And it couldn't be because I didn't pick a number out of my solution set. This is kind of reverse psychological tactics.